Okay, so here's another example of an indirect proof. And like I said before, some things that indicate to me immediately that this is an indirect proof is that I'm trying to prove that AH does not bisect angle MAT, and in the givens I also have that two segments are not congruent. So that's how you would know right away. So let's use our template to kind of fill in the blank. So if we look at our proof statement for this, either AH does not bisect angle MAT, or the only other possibility would be that it does bisect angle MAT. And then we always want to assume the opposite of what we're trying to prove. So let's assume that AH does bisect angle MAT. And then let's kind of go from there. Now this is a part of your proof that it does bisect angle MAT. So what would that mean? Well, I'm going to put numbers up here. That would mean that angles 1 and 2 have to be congruent. So right from here, that's where I'm going to start my paragraph proof. So angle 1 is congruent to angle 2 because if a ray bisects an angle, it divides it into two congruent angles. Alright, so I'm going to go ahead and put tick marks there. And now I'm also going to not forget to use this top given here. Since AH is perpendicular to MT, then we know that angles 3 and 4 must be right angles, because perpendicular segments form right angles. Then we know that angle 3 and angle 4 are congruent because right angles are congruent. AH is congruent to AH by the reflexive property, so then the triangles are congruent by angle side angle. And again, remember, we're trying to reach that contradiction, so now we can say that segment MA is congruent to segment AT by CBCTC. And now that we are at that contradiction, this is where we're going to stop our proof, but this contradicts the given statement that MA is not congruent to AT. So our assumption was false, therefore, since our assumption was false, the opposite of that assumption has to be true. AH does not bisect angle MAT. And that would conclude this indirect proof. So let's try one last example. Okay, in this last example, example 3, we're given circle Q and angle 1 is not congruent to angle 2, and we're trying to prove that S is not the midpoint of PR. So let's set this up the same way we set up the other two proofs. So either S is not the midpoint of PR or S is the midpoint of PR. Let's assume the opposite of what we're trying to prove. So let's assume that S is the midpoint of PR. So if we use that as a given, what would that mean? That would mean then that PS is congruent to SR. Because if a point is the midpoint, it divides it into two congruent segments. And since we know the center point of the circle is Q, we can look for those radii. So we would know then that PQ is congruent to QR because all radii of a circle are congruent. We can use the reflexive property on QS to get the triangles congruent by SSS. Once we have the triangles congruent, now we can say that angle 1 is congruent to angle 2 by CPCTC, and that is our contradiction, so we can go ahead and then stop our proof here, but this contradicts the given statement that angle 1 is not congruent to angle 2, so our initial assumption was false, therefore S is not the midpoint of PR. So hopefully now you have a better idea of how to complete a proof indirectly. Remember, look for those key things like proving something's not a midpoint or does not bisect an angle, or two things are not congruent. That's going to indicate to you that this is an indirect proof versus a direct proof.